Hello students, and in this video we're going to go over some important information from Chapter 10 on calculations for infusions. And then we'll also do some examples that will help you with the homework in Chapter 10. So first up, I'd like you to consider doing the practice problems at the end of the section on pages 298 and 299 before beginning the homework. Okay, so the practice problems I'm talking about are here. Okay, so they occur before the exercises for Chapter 10. So in the ebook, these practice problems are on page 299, but in the hard copy of the book, they are on pages 298 and 299. Okay, so consider doing these examples, okay, before starting the exercises. Okay, so before we go through some examples, okay, let's go over some important information that will help you understand how to do the problems in this section. Okay, so at the beginning of the section, you have the introduction to enteral and intravenous solutions. Okay, and the basic idea is that fluids can be given to a patient slowly, okay, over a period of time through a vein, okay, which means intravenous, okay, or through a tube inserted into the alimentary tract, which is called an enteral feeding. So the rate at which these fluids flow into the patient's body is important and must be controlled precisely. Okay. So when we refer to enteral feedings, right, those are given when a patient cannot ingest food, or if the upper gastrointestinal tract is not functioning properly. Okay, the prescriber may write an order for an enteral feeding, which is also known as a tube feeding. Okay, and we won't discuss tube feedings as much, but we'll focus more on intravenous infusions. But if you want more information about enteral feedings or tube feedings, okay, please see page 279. Okay, and then enteral feedings, okay, may be given continuously, okay, which is over a 24-hour period, or intermittently, okay, over shorter periods, perhaps several times a day. Okay, that's also true for intravenous infusions. Okay, intravenous infusions may also be given continuously or intermittently. Okay, so in order for an enteral feeding, okay, or intravenous infusion, okay, should contain the following information. Okay, so it should have the name of the solution that is being infused into the patient's body. It include the volume of fluid to be infused over a period of time. So in other words, if you have the volume and then the time period, right, then you have the flow rate. So basically, you need to know the rate in which the fluid is flowing into the patient's body, called the flow rate. And then lastly, you need the route of administration, okay, such as a feeding tube, an IV, an IVP, or an IVPB. Okay, so when we talk about intravenous infusions, okay, there are different ways. Okay, there's your regular IV infusion, okay, which could be an IV piggyback, so IVPB, or IV push, IVP. Okay, so just like enteral feedings or tube feedings, intravenous infusions, right, may be given continuously or intermittently. Okay, so intravenous infusions that are given continuously means the IV infusion is given over an uninterrupted period of time, right, such as for several hours, okay, for up to 24 hours, okay, and then intermittently means the IV infusion is given over a shorter period of time, such as for a few minutes, for perhaps several times a day. Okay, so before we go on to point number 3 here, you should also familiarize yourself with different intravenous solutions that are used in healthcare. Okay, so a common solution is what's called a saline solution. Okay, and a saline solution is a solution of sodium chloride, which is abbreviated as NaCl. So Na for sodium, Cl for chloride. Okay, so a saline solution is a solution of sodium chloride in sterile water, right, and is commonly used for an intravenous infusion. Okay, and there are different types of saline solutions. Okay, you have normal saline, which is 0.9% NaCl. We also have half normal saline, which is 0.45% NaCl. Okay, which is sometimes written as the fraction 1/2 followed by the capital letters NS for normal saline. Then you also have quarter normal saline, which is a 0.225% NaCl solution. Okay, which is sometimes written as the fraction 1/4 followed by the capital letters NS for normal saline. So intravenous fluids generally contain dextrose, sodium chloride, or electrolytes. Okay, so these are some other common intravenous solutions, such as D5W, okay, which is dextrose dissolved in water, okay, or normal saline, or 5% dextrose and then 0.45% NaCl. Okay, so it's a combination of dextrose and normal saline. And then you have Riener's lactate, okay, also called lactate Riener's, okay, which is a solution containing electrolytes, including potassium chloride and calcium chloride. Okay, so point number 3 here says you want to familiarize yourself with common drop factors for IV tubing. Okay, so the drop factor for an IV tube tells you how many drops equal to 1 milliliter. So the drop factor will either be expressed in macro drops or micro drops and can be found on the packaging for the tubing. Okay, and I encourage you to see page 284 for more information. Okay, so at the bottom of the page 284, you'll see table 10.1, okay, which tells you common drop factors for macro drops. Okay, so for example, the abbreviation for drops is GTT. So GTT stands for drops. So 10 drops. So a common drop factor is 10 drops is equal to 1 milliliter. Okay, another common drop factor is 15 drops is 1 milliliter, and then 20 drops is 1 milliliter. So again, how do you know which one to use? Right, it'll either say in the problem, okay, or you'll see a picture of an IV tube label, okay, and on the label it'll tell you how many drops are in 1 milliliter. So for example, in this label here, right, it says that 60 drops is approximately 1 milliliter. Okay, so when you look at a label for tubing for an IV, okay, the drop factor should be on the label. Like in this one, right, 10 drops is 1 milliliter. Okay, so again, either the drop factor will be provided in the problem, okay, or you can find it on a label for IV tubing. Okay, so I encourage you to read pages 279 through 285 for more information about the topics we just talked about. Okay, so without further ado, let's start some examples. Okay, so for some of the examples in the homework, you're going to be asked to calculate the flow rate. Okay, so the basic formula for flow rate is as follows, right? So the flow rate is equal to so the flow rate is equal to volume divided by time. So volume over time. Okay, and the flow rate can be expressed in milliliters per hour or drops per minute, okay, depending on the problem. All right, so the order reads, so normal saline, 1000 milliliters IV, infuse over a 24-hour period. Okay, so we have the name of the solution that we're infusing, the amount of solution, okay, given in milliliters, okay, the method or route of administration, which is through an IV, okay, and then the period of time. Okay, so with the amount of solution, which is 1000 milliliters, and then the period of time, which is 24 hours, all right, we can easily figure out the flow rate. Okay, so it's going to be equal to 1000 milliliters okay, over okay, 24 hours. Okay, and what we want to do is simplify that as much as possible. Okay, so it's going to put that in our calculator. So 1000 divided by 24. All right, if we don't get a nice whole number, okay, we get this decimal. Let's go ahead and round it to the nearest whole number. Okay, so the approximate flow rate, if you round it to the nearest whole number, would be about 42 milliliters per hour. Okay. Now, in some cases, you can round to the nearest tenth. So, either 41.6 milliliters per hour or 42 milliliters per hour. Okay, would be the flow rate. So that's the answer for the first example. Okay, so I'm going to go ahead and round it to the nearest tenth. Okay, but usually we're going to go ahead and round that to either the whole number or the nearest tenth. Okay, so 41.6 would be the answer. So is the flow rate. Okay. All right, let's go and try another one. So we have an order for D5W, which is dextrose and water, so 5% dextrose and water. Okay, 2000 milliliters via IV, and we're going to infuse that over a 12-hour period. And then furthermore, it says that the drop factor of the tubing is 10 drops per milliliter. So remember, GTT is the abbreviation for drops. Okay, so you want to calculate the flow rate in drops per minute. So remember that the flow rate is the volume divided by the time. Okay, so we're going to take the 2000 milliliters and divide it by the 12 hours. So 2000 milliliters over 12 hours. All right, and notice that this problem wants the flow rate in drops per minute rather than milliliters per hour. Okay. So what you can do is you can put that in the calculator. So 2000 divided by 12. Okay, if it gives you a decimal like that, go ahead and round it to the nearest whole number. Okay, so this is equal to 167 milliliters per hour, okay, to the nearest whole number. So ideally, you should not do any rounding until you get your final answer. Okay, but let's see if we can get as close as we can to the final answer. So this is the flow rate, okay, in milliliters per hour. All right, but we want the flow rate in drops per minute. Okay, so we're going to perform two calculations here. So we're going to multiply by the drop factor, which is 10 drops per milliliter. All right, and then multiply by 1 hour over 60 minutes. Okay, so we have 167 times 10, and then divide by 60. And we're going to round that to the nearest whole number. So 27.8, so that's approximately 28 drops per minute. So 28 drops per minute is the given flow rate.